Today's video is on I can estimate fractions and decimals. So hopefully you have already opened up your fractions and decimals notes sheet. You should have that either as a printed out copy in front of you, or if you have it open in Notability, you can use that as well and it's fine. So please, to start, you can write down our learning target, which I have written here. Our learning target is I can estimate fractions and decimals. I've already written it down. Your I know, that is what you're going to write about what you already know about estimating fractions and decimals. So maybe you write, I know how to round decimals, or I know how to find the closest whole number to a fraction, whatever that is. And then after you put down what you already know, the next thing you're going to do is your estimate. So our vocabulary word is estimate. Estimate means to find a value that is close enough to the right answer. I really like that it says close enough. Estimate means we're not finding the exact answer, we're finding one that's close enough. So at this point, please pause the video and get all of this written down, and then restart the video when you're ready to start the problems. So hopefully you have now paused the video, written down all of these things above, and are now ready to take your notes. We're going to start by estimating decimals. So when we estimate decimals, the way this is going to work is we are going to have a problem and we are going to get an estimate instead of finding the exact answer. So for our first problem, we're going to do 8.3117 plus 2.995. Now, the trick key here is that we want to estimate the answer. I don't want to find the exact answer. I want to find an estimate. So what I'm going to do is I'm going to round. I'm going to say 8.3. Well, 3 would make it rounded down. So 8.3117, that's going to be pretty close to the number 8. And if I look at the number 2.995, 9, that would make it round up. So 2.995, I'm going to say that's pretty close to the number 3. And I'm adding these two numbers. So my estimate would be 8 plus 3 equals 11. Now this isn't the exact answer. This is the estimate. But in this case, we were only asked to find the estimate. So this would be my final answer. Okay? I'm going to give you another problem. After I give it, if you want, you can pause the video and see if you can find the estimated answer for this problem on your own. This time we're going to do 12.1175 minus 0.8993. Again, if you want to pause the video right here, see if you can come up with the estimate on your own. If you're done coming up with the estimate on your own, we're going to look at this, okay? Here I have 12.1175. I know 1 would make the number round down. When we round a number down, it stays the same. So my estimate would be 12. 12.1175 rounds. It's really close to the number 12. 0.8993, well, 8 would round the number up. Again, I'm always wanting to round this to the nearest whole number so that this becomes a really, really easy problem to estimate the solution for. 0.8993, 8 would make it go up. So 0.8 is going to round to the closest whole number of 1. So if I say, okay, 12 minus 1, that would also be 11. And that is my estimate. Again, we're not trying to find the exact answer. For this, we're just finding an estimate. Okay? I'll do one more example with decimals. And again, if you want, you can pause the video and do it on your own. The problem this time is going to be 7.39949 times, 7.39949 times 3.512. So if you want, you can pause, round each of these to a whole number, and see what your estimate is. Otherwise, I'm going to move on and I'm going to solve the problem. 7.39949. Well, I know that the 3 after the decimal, that would make it round down. So this is going to round to the number 7. 3.512, would make my number round up. So instead of 3, I'm going to have 4. Then I have 7 times 4. That equals 28 for my estimate. Okay? And that is how we're going to estimate with decimals. We're always just rounding to the nearest whole number to see what answer would be close to the answer if we actually solve these problems. We're going to move on now to estimating fractions. Okay? With fractions, it's going to look something like this. Let's say I had 8 1/3 plus 2 7/8. Again, I want to find the closest whole number to each of these values. 8 1/3. Well, 1/3, I want to know, is that closer to 0 or closer to a whole? Well, 1/3, that is closer to 0 than to a whole. If I were to write a little number line, and we'll be learning more about number lines later, I would say 1/3 looks like that. Or I could say if I had a box and I split it into 3 pieces and only one of them was shaded in, well, that's not very much of the whole thing. So 1/3, I'm going to say that's going to make my number round down. So instead of 8 1/3, we're just going to have the number 8. 2 7/8, if I had a rectangle and I filled in 7/8 of that rectangle, well, that would be that much of the rectangle. That's most of the rectangle, so that's almost a whole. So instead of rounding down to 2, I'm going to round up to the next whole number, which would be 3. So my answer here is 8 plus 3, which means that my estimate, my answer, is pretty close to 11. Okay? One more example here with fractions. And again, if you want to try to solve the problem on your own, you can do that. I'm going to do 7/8 times 1 1/2. Well, again, I'm imagining, is this closer to a whole or closer to nothing? So for this one, I'm going to say 7/8. And if you want to, please, again, pause this, see if you can come up with the estimate on your own. Otherwise, I'm going to finish. 7/8, I want to know, is that closer to nothing or is that closer to a whole? Well, up here, I showed that that's closer to a whole. So I know 7/8, that's pretty similar to the number 1 whole that would round to. Times 1 1/2. Well, for a half, I know that it would be filled halfway. We also know 1/2 always rounds up from when we were rounding decimals before. So 1 1/2, that's going to round up to 2. So my answer here is going to be pretty close to 1 times 2. So my estimate is going to be 2. So that's how we're going to estimate fractions and decimals. As always, please let me know if you have any questions, and have a great day.